how to justify our different answers, how to write good reasons, things that'll get you points, things that are solid, and that they're not like an incomplete reason or have good rationale. Your because statement is where you're going to get your points. So we can know that F is increasing because, and then what would be true? Okay, what? Okay, F would be increasing because? Okay, F prime of X, and you don't have, you can write the words is positive, or you can use the mathematical terms. Now we cannot know that F is increasing with anything to do with the second derivative, so there is no rationale that you would connect for that. F is decreasing if or because negative. All right, F of X has a relative maximum. How could you justify or prove that? Okay, F prime of X changes. Positive to negative. Is there any way to prove that you have a relative maximum based on the concavity? Okay, any negative concavity? Negative concavity combined with what? F prime of X being equal to 0. It has to be the combination of two things. Okay, so F double prime of X being negative and F prime of X being 0 or undefined. The undefined is important as well. Okay, you could have either of those. So having a maximum, you need to either show a change in the first derivative, or if all you have is a second derivative to work with, you need to show the sign of the second derivative along with the 0 or undefined value in the first. And then the minimum is sort of the opposite. So we'll have F prime of X changes negative to positive, or F double prime of X is greater than 0, so it's concave up, along with, at the same time, F prime of X being equal to 0 or 1 over 0, which is undefined. So those two things. So if you forget the and part, you often would get a note from me or a note from the grader, insufficient. It's not enough just to have one. You got to have both. Okay, concave up and concave down. We can't do anything of that, nor can we do anything with points of inflection with the first derivative. Those are only based on the second derivative. So concave up would be the second derivative being positive. Concave down would be the second derivative being negative. And a point of inflection would be the second derivative changes. It doesn't matter how it changes. It just can change from positive to negative or negative to positive, but some changes somehow from one to the other. So I want to drop down to the exam tips down in the bottom corner for this one. Okay, give sufficient reasons. All right, so make sure that you don't leave any part of that out when you're writing it out. Okay. The other thing is kind of similar to the know thy exam. One of the tips she gave in there was even if you don't know one of the answers, you can like fake it till you make it, right? Say, I don't know where the minimum is going to be. But let's say the minimum is at 7. Have your favorite number ready, okay? I know that minimums exist because this is where the first derivative changes from positive to negative, okay? So you can like make it up and give a reason even if you have the wrong value, if your reason is still showing that you know what a minimum should be, okay? So that's another tip. Fake it. It's okay to give reasons and validations, even if you don't have the right answer. Put it in your own words, okay? So even if you don't have an accurate value, if your reason is still good, you're still going to get points for it. All right, so then our sample problem in this section is going to be reading the following graph. And a key to reading this graph is understanding that you are looking at a graph of the derivative and not a graph of an original function. This is a derivative function. It's a semicircle and two linear pieces. And so I find, maybe this is another exam tip you can answer, like I answer the questions before I even look at the graph. Okay, on which open intervals is h decreasing? I would answer it, h will decrease when, and then what's my reason? H prime of x is less than 0. So that's my reason first. Wait, well, where am I going to find h prime of x? H prime of x is the graph. So where is h prime of x less than 0? -9 up to -3. Okay, so period. This occurs from -9 to -3. I often do the same thing for the next one. For which values will I have a relative minimum? I answer the justify part first. H of x will have a minimum when h prime of x changes from negative to positive. And then I say, this occurs at, and then I look back at my graph and I figure out where that's happening. That helps me. Then I know I've got the points for the justification. And then I look back, all right, where is my graph changing from positive to negative? X equals -3. That looks to me like it's changing from negative to positive. Okay, and that's what we want, right? Not doing positive, negative. All right, so we've got -3. All right, and then the last one, when will it have a point of inflection? H of x has a point of inflection when h double prime of x changes nature. Now, I don't have h double prime of x. I only have h of x. Okay, so I would say this occurs when the slope of h prime changes nature. And then I'll look back at it. So then this occurs at x equals. And then we'll go back. All right, when does the slope change nature? Okay, where do you see that happening? 0 is one of them. 3 also. Okay, well, -3 changes slope, but it's not changing nature, because as it approaches -3 on that upward part, it has positive slope. And then as it goes on to the semicircle, it still has positive slope. So it is changing, but it's not changing nature. Nature means it has to change direction from positive to negative or negative to positive. Nope, not for that. Okay, not for points of inflection. Okay, yeah.
With the second sentence, like, the absolutely necessary is okay if you just would have.
That's just for me. Like, as I know, it's not necessary, but that's how I'm like thinking and processing how it goes.
Will I get extra points if I write the second sentence?
No.
Okay.